We are going to be looking at section 5.1, which is understanding linear functions. So the first topic that we're going to be looking at is recognizing linear functions. So what that means is being able to look at an equation and determining if that is linear or not. So one way to help us do that is to kind of look at what the standard form of a line is. So for the standard form, we are going to be using ax plus by equals c. So kind of looking at and breaking apart the equation of a line, you'll notice that we have an x and a y. A, b, and c are all just real numbers that are not 0. Or I should say A and B can't be 0, because then you would have no x or no y, which would leave us with nothing. So you'll notice that we don't have any exponents, we don't have any variables in the denominator, and that will kind of help us determine whether something is linear or not. So for the first example, it says determine if the following is linear or not. So our first equation, we have x squared plus y equals 3. So right off the bat, we can see that we have this squared, and that's the part that makes this not linear. And we're kind of learning as we go here. So I'm just going to make a note that exponents are not linear. So that's something that will be an easy way of telling right away. The next equation, we have 2 over x plus y over 8 equals 1/3. So I know if we have something like y over 8, we could also write that as 1/8 y, right? So we have 1/8 of a y. But 2 over x, we really can't write that in any other way. So anytime you have a variable in the denominator, it's also not linear. So this one would also be not linear. And then I'm going to make a note here that if you have variable in denominator, then it is not linear. So those are kind of the two things that we'll see. Also, like square roots would make it not linear, but most commonly you'll see exponents and variables in the denominator. Our last one, we have x over 3, which I could really write as 1/3 x equals 12y. So this one is linear. Okay, so our next kind of main topics, we're looking at 3 topics. The first one is just recognizing linear functions. Our next one is graphing linear functions in standard form. So we want to determine if the equation is linear, and then if it is, we do want to graph it. So looking at this, I can tell that it is linear. So because it's linear, then I want to graph it. So I like to put things in slope-intercept form, which is in that y equals mx plus b. That will kind of make it easier because most of us recognize that form and are able to graph it. So the first thing I'm going to do is go ahead and subtract that 3x to the other side. So we're trying to get y by itself so we can get it into that slope-intercept form. The next thing that we would need to do is divide everything by -1. So we would get y equals 3x and then plus 4. So now it's in slope-intercept form, which will make it a lot easier to graph. And then we're going to go ahead and start drawing our graph. I am going to go by 2s. So just so we know, be careful. The book often will change the scale to random things. So you just need to make sure that you're paying attention to that. Okay. So looking at the graph, and I'm actually going to use like a different color. So we want to start at 4, since that's our y-intercept. So we start at 4. And from there, I'm going to go up 3 over 1. So remember, we're going by 2s. So it's up 1, 2, 3 over 1, up 1, 2, 3, over 1. I could also go down 3 over 1, down 3 over 1. And then from there, you are going to connect it. Okay, so that is our first one. So looking at the next one, we want to determine first if it's linear or not. And we can tell it's linear because it has no exponents and no variables in the denominator. So I'm going to do the same thing as I did last time by moving it into slope-intercept form. So I just subtracted that 5x to move it to the other side. And now I'm going to go ahead and set up a graph. And I will be going by 2's again, just because we have a y-intercept of 10. So we want to make sure that we're able to fit that on our graph. Okay. So we'll start with our y-intercept of 10. And from there, we want to go down 5. So that's 1, 2, 3, 4, 5 over 1. And we'll do that again. Down 1, 2, 3, 4, 5 over 1. And then you will then connect those dots. Okay, so looking at both of these graphs, you can see that the first one that we did had a positive slope, and that makes sense because when you look at the graph from left to right, it's increasing. And our second one has a negative slope, and that makes sense because when you look at the graph from left to right, it's decreasing. Our last topic is going to be modeling with linear functions. So it doesn't really give us much here, but I'll kind of help guide us to what we need. So all we have is Chelsea dog sits and charges $30 per visit. So the first thing I want us to do is come up with the function. So we know that for a function, it's going to be f of x, and it's really just going to be 30x, because that's $30 per dog visit. So we do want to identify that x represents the number of visits, and f of x is going to represent the amount of money earned. And then we also want to make kind of a table to start helping us think about what the graph is going to look like. So obviously, for 0 hours worked or 0 visits, she'll make $0. For 1 visit, 30. For 2, 60. And for 3, 90. So we're going to go ahead and set up a graph. So far we have our function. We've labeled our x and f of x, and then we're going to go ahead and set up a graph. So our x-axis is going to be visits. And then our y-axis is going to be the money earned. So I'm going to say that this is 30, 60, 90, which makes this 15, 45, and 75. And then from there, we're going to plot our points. So for 0 visits, it's $0. For 1 visit, it's $30. For 2 visits, 60, and for 3, 90. So our next big question is we want to decide if we need to connect these dots. So if we connected them, that would be saying that I can have 1.5 visits for $45, but technically that's not true. So all we know is that we have 1 visit is this amount, 2 visits is that amount. So this would be a situation that is discrete, which means that we are not going to connect them. And then lastly, we're just going to go ahead and write our domain. So our domain is all possible x values, and we have to list them because they're discrete. Now it's going to go on for however many hours she worked, so I'm just going to do the ... And then we have our range, which is the money earned. So that would be the y values. So I'm just showing a few So we can see what the pattern is, and then I'm doing dot, dot, dot to show that it's going to continue in that pattern, but we are not going to go on forever with writing our numbers.